So we all right. So today we're going to talk about the consequences of what happens when you use one little sample to make a big decision about the population. So it should make sense to you that samples are variable. So looking back here, imagine the dot plot of the sampling distribution. You could just by chance get any one of the samples on that dot plot. What happens if you get a wonky sample? What happens if you just happen to go to Rayleigh's and get a bag of M&Ms and there's all blue in there? And it's just like random chance. So there's two different mistakes that can be made. And the really fun part about this lesson is that if I do a good enough job, unfortunately, you're going to start to see type 1 and type 2 errors throughout all of life. Every time you make a conclusion incorrectly, an incorrect conclusion about anything, you're like, oh, type 1 error, oh, type 2 error, and then you're going to be like, darn you, you've infiltrated my brain. So this is one of those topics that if you're like trying to feel smart at a dinner party or a conversation, just bring up the type 1, type 2 error because it applies to everything. Anyway, okay. So we're going to define them first. And then I want to take a look at this page that I printed for you. So I asked Google to do a little like AI summary. And then I thought it was actually so good that I printed it last night. So anyway, okay. So what is a type 1 error? And what's a type 1 error in stats class? Like what for a math problem? The sample led you to conclude you should reject the hoe. It can be funny all year. It's great. I hope it's funny all year. The sample led you to conclude you should reject the hoe. Okay, so you're doing your research. You got a bag of no blue M&Ms in it in your pants, right? You're like, what is this crap? That machine's broken. I feel like if I put some kind of emotional feeling into it, it'll help you remember. Okay, you're like Chris, you're like, there's something wrong here. Okay. However, it wasn't really broken, it was just a wonky sample. Do you guys see how that could be possible? Just by sampling variability, just by chance that you get a weird sample and it leads you to make the wrong conclusion. Okay, now for those of you that are following my kind of court case narrative, this would be someone who is found guilty when they're actually not guilty. And for the rest of the world, when I tell you to apply this lesson to your entire life, a type 1 error is a false positive test. So you take that COVID test, it says you have COVID, but you actually don't have COVID. Okay, let's go over to my little sheet that I printed for you. Give your hand a break. I heard through the grapevine there was a lot of writing in the homework, so we'll just give your hand a break for a second. And Mrs. Talbot, gotta tell you, there's a lot of writing every day in your class. I know. But can you imagine the amount of writing there was before Mr. Talbot told me that I should make these little arts and crafts bits? There was way more. Okay, so here's my fun example of a type 1 error. Type 1 error. often called a false positive, occurs when the null hypothesis, in this case, the null hypothesis is the defendant is innocent, which should be the null hypothesis in every criminal case, by the way, is rejected when it's actually true. In the Shawshank Redemption, this is pronounced Dufresne, by the way. Andy Dufresne is convicted of murdering his wife and her lover despite his innocence. And it's super cool in the movie because it makes you wonder, like, at first if he actually did it or not. And then later in the movie, it's revealed that he didn't do it. But anyway, the error, the justice system rejected the true hypothesis, Andy is innocent, and accepted the false alternative, Andy is guilty. And this represents convicting an innocent person. And then it's kind of sad if you think about that and how often that might happen. Which one's worse, by the way? I'm gonna let you ponder that on your own. That'd be a fun debate, right? What's worse in a criminal case, type 1 or type 2 error? Okay, anyway, type 2 error is the opposite. The sample led you to conclude you should fail to reject Ho. When you should have rejected the Ho. Okay, what do you guys think this is in terms of court cases, like in my parentheses up here? Yeah. Found not guilty when someone's actually guilty. This also happens a lot. And then in the rest of life, this is a false negative. So you take that COVID test, it says you don't have COVID, but you do. Some sort of mishap with the test. Okay, now, because you don't have a note card, I have devised a fun way for you to remember. So type 2 error means you failed to reject. That's just a Mrs. Talbot dumb thing to help you remember. Okay, then give your hand a break. Go over to the printout. We're going to read about type 2 error, which I'm sure that you guys have much more information about in your mind. A type 2 error or false negative occurs when the null hypothesis, the defendant is innocent, is not rejected even though it's false. This means a guilty person is acquitted. In the 1995 O.J. Simpson criminal trial, the jury found Simpson not guilty of the murders of Nicole Brown Simpson and Ron Goldman, which, by the way, was not her lover. And I didn't realize that. He was just a guy who returned her glasses to her. Because I watched the O.J. documentary anyway. Okay. The error. Many legal analysts and the public argue that the jury failed to reject the innocence hypothesis, did not convict when the defendant was in fact guilty. Okay, now to be honest, we don't know. You know, I mean, yesterday when I was talking about this, everyone was like, very heated one way or the other on the topic. And I was like, you don't know. He didn't say, I don't know. Anyway, he probably, anyway, there's a lot of, it's kind of suggested that maybe perhaps we got that one wrong. Anyway, okay. This represents letting a guilty person go free. Okay, now this is fun, and I want to talk about the bottom real quick, just for fun. And not just for fun down here. This is actually going to come up in a minute. The O.J. Simpson acquittal is often cited as a failure of the prosecution to meet the beyond a reasonable doubt standard due to sloppy investigation, mishandled evidence, and contamination. Highly recommend the documentary. Just saying, if you're, interested in how they screwed that up. It's fun. Okay, the system's bias. The legal system is intentionally designed to minimize type 1 errors, convicting the innocent, often making it easier for type 2 errors, freeing the guilty to occur. And you could argue that it would be worse to find an innocent person guilty. You could make an argument for that. I feel like our debate team should take that one on. I'd love to watch it. Okay, anyway, and then this is important for stats. The civil trial. In a stark twist, the 1997 civil trial found O.J. Simpson responsible for the deaths, illustrating that a different standard of evidence, preponderance of evidence versus beyond a reasonable doubt, can change whether an error is perceived to have occurred. Okay, do you guys know what a civil trial is versus a criminal trial? A civil trial is for money. So Nicole Brown's family and Ron Goldman's family sued him for money damages. That's what a civil trial is. The criminal trial was guilty or not guilty, go into jail. Civil trial is money. I want no money because you screwed us over, which, And civil trials, you only have to prove a preponderance of evidence. But criminal trials, you have to say beyond a reasonable doubt. You have to be really sure. And I want to bring that back later in a second. Okay. Back to this. How often are we wrong? Is what we need to talk about. Do you think that wrongness happens a lot? Do you think that because you're taking one sample and making a decision, wrongness happens a lot? Okay, I'm going to tie it back to something that you know more about. Okay, if you are 90% confident about something, how often would you expect to be wrong? Okay, 10% of the time, right? Okay, so if you have a 90% confidence level, that means you expect to be wrong about 10% of the time. This is aligned with an alpha level of 0.10. Okay, let me say that again. If you're 90% confident, that means you're expecting to be wrong about 10% of the time, which aligns with an alpha level. What's an alpha level? That's the boundary, yep, of which you're going to reject or fail to reject. Okay, so the probability, and we write it like this, the probability of a type 1 error. Yes, I realize I'm taking up tons of room on my paper. You do not need to. The probability of a type 1 error is very easy to find. It's just whatever the alpha level is in that problem. So if the alpha level is 5%, you expect to be wrong 5% of the time. If the alpha level is 1%, you expect to be wrong 1% of the time. And when I say wrong, I mean specifically wrong as in type 1 error. Okay. The probability of a type 2 error is really hard to calculate, and we are not going to calculate it straight out. However, it might just make sense to you that as the probability of a type 1 error goes up, the probability of a type 2 error goes down. They have an inverse relationship with each other. Okay. So do you remember how I talked about those 3 alphas, the 3 most common alphas? Okay, so the last thing we're going to do on this bit, list them in order from the most popular ones. They don't have to be these, but I think these are the ones that you're going to see in this class. I don't know that you'll see any other ones, honestly. I'm thinking about like all the problems for the whole rest of the year, and I'm pretty sure it's these. Okay, this is a very, very strict boundary, 1%. Probability of type 1 is very low in that case. And this is the alpha level that they use. I mean, it's not a math problem, but this is what they would use in a criminal situation because you don't want to commit a type 1 error. 0.05 is the middle of the road. And this is the one that you should use if you're not given alpha in a problem. You should use 0.05. It's a nice middle of the road. And then 0.10 is the least strict. The probability of having a type 1 error is higher. And this is what I was talking about in a civil case where they're just talking about money. Probability of type 1 error isn't like life or death or locking someone up, so you don't have to prove as much. So when they said on the paper I gave you, preponderance of evidence is more like this, beyond a reasonable doubt is more like that. Okay. Go ahead and arts and crafts. And I have mixed some review from yesterday into today's. So it's not really short, but that's because I wanted to go over yesterday's stuff again. I think there's 2 arts and crafts things today. What? I don't think I was there. I can't believe I don't know how but so, so just a reminder, again, if the rest of the document is not short, it's not that, it's not that, like, there's more to learn. It's just that I wanted to mix the review from yesterday in with today. And this particular problem really is yesterday's, but I just think it's important. I don't know, I just mixed it in. And I looked at it this morning, I was like, okay. There's a lot, but that's okay. Also, I'm gonna go on the next page after this, but you don't have to if you don't want to. It's just because I wanted to keep my type 1 and type 2 error sentences next to each other, but if you have more room on your page, feel free. Okay. A fast food restaurant manager wants to reduce the proportion of customers who wait longer than 2 minutes to receive their food. That's a good idea because Mrs. Talbot probably wants her fries. According to store records, the proportion of customers with a long wait time is 63%. Holy moly, that's not good. Okay, anyway. First thing I want to ask you is this problem about means or proportions? Proportions, okay. And remember, null hypothesis is always equals. And what is the current claim? What is the null hypothesis? What do they know right now? 0.63. Okay, now he wants to reduce the proportion. What symbol is reducing? Less than. Okay, what's the true proportion of what in this problem? Yep, okay, so you can write customers with a long wait time because that's shorter. Okay. Super important to me that you guys are comfortable doing this bit. So when we get to the FRQ part of the chapter, this will be the state. The only other thing you'll have to add is the alpha level because you should state that ahead of time. ethically speaking, the boundary should be set before you do the math. Does that make sense? Okay. Any questions about that before we move on? That's yesterday's stuff, but still importante. Okay, now we're gonna switch it to today's stuff. And then I'm gonna show you how I would suggest that you do this on a test because you have to memorize. So I'm gonna show you how I use my like muscle memory, like literally my muscle memory to help me memorize which is which. Okay, so let's pretend I'm taking the test and I'm asked to write the type 1 and type 2 error in context for a problem and give the consequences. And I have no reference as to what those mean, so I'm going to use muscle memory to help me. Describe a type 1 error. Okay, so I go to my hypotheses and I reject the null hypothesis. Okay, do you see that I am physically with my hand rejecting the null hypothesis? Okay, and so what I'm going to do is I'm going to conclude this incorrectly. Okay, so I'm going to go with the manager being a guy. I don't know why. I'm going to actually not write that word either. Mr. Knight threw me off. Okay, type 1. I put my finger over the null hypothesis and I conclude the alternative hypothesis incorrectly. Okay, again, probability of type 1. I put my finger over the null hypothesis I conclude the alternative hypothesis incorrectly. Okay, now, in like, going back to the pretend you're the restaurant manager, you concluded that the proportion of people who wait is less than 63% when it's actually 63%. What is that? What's that gonna, how are you gonna proceed with that incorrect information? What are you gonna do with your business, with your fast food restaurant? What do you think is happening? Yeah, so you think people are being served quickly, but they're not. So you're not gonna make, you're not gonna make any like needed changes, right? You think people are being served quickly, they're not being served quickly, so you're gonna be like, oh, everything's fine. And you're not gonna put in any process changes or do anything that you should probably do. Okay, so I'm just gonna say, and this is for the consequence. He thinks people are being served quickly, but they're not. They're sitting there. You know, Mrs. Talbot sitting in her little car, upset about no fries being produced. Actually, I like it when they make the fries fresh, so if I have to wait a minute, I don't actually mind. But anyway, you know what the worst thing is about fast food working with the fries is people that come and ask for no salt. Do you want to know why? You don't even think about how that would be terrible, but there's salt covering the entire like workspace of the fries. And so you have to like take out the fries and put them on like a separate tray. And like it has to, anyway, and you have to like blot it all off because there's not like the mechanism that okay. Might be some past trauma there. All right, probability of type 2 error. Okay, so for probability of type 2, you cover up the second thing and you say, okay, I'm concluding that the proportion is 0.63 when it's actually less than 0.63. Muscle memory. Okay, what's the consequence here? Perfect. I couldn't have said that better myself. If you want to come over here and take the podium, I can be done. Excellent job. He's going to spin his wheels. He's going to make all kinds of process changes gonna be upset, yell at the employees, and everything's fine. I wish I could tell you that didn't happen very often in business. Okay, all right, you guys, which is worse in this case? The first one, I think, because there's angry customers out there, right? What? Yeah, well, they don't ever care about work staff. They care. It's true though. You know it's true. They care about customers. So there's angry customers in this situation. I do feel bad for the work staff. Trust me, as you can tell, I did work the fast foods. But in this case, the angry customers, okay. And I feel like we could all debate all of these. I feel like every single one of these, you could almost debate which is worse, but I'll try to make it obvious for you if I ask. Um, angry customers means type one for serious. Let's just go with that. Okay, how do you lower, says, is this type one is serious? How do you lower the probability of type one? Okay, if type one is bad, how do you lower the probability of type one? Smaller alpha level. Yeah. So you want to move to where your probability of type one is lower, which would be a lower alpha level. Okay, go ahead and arts and crafts in that last bit, and then we're going to review yesterday's 2 annoying sentences, and then we're done. All right, guys, so we're gonna write two annoying sentences. I know you want to be done writing, so do I. Here we go. Okay. The manager assigns an additional employee to fill orders, collects a random sample of 250 wait times, and finds that p hat equals 0.576. Nice. Good job, manager. Went down. And p-value is this. Interpret the p-value in context and write the conclusion. Okay. Annoying. That's fine. How does the p-value interpretation start? What's the first word? Assuming. That's supposed to be an I. It looks like a J. I don't know what's happening. Assuming. Okay, what's after that? Okay. Do you guys care if I use last year's notebook, which is not nearly as pretty? Okay. Assuming the null hypothesis is true. Okay. Assuming P equals 0.63 is true. Do you guys know where I got that from? Okay. There is a great job. P value 0.0385 probability. Yep, getting a sample proportion. This problem is about proportions of, okay, what's the sample proportion in this problem? Or less. Nice. Callie's on fire. Okay. Practice that one. Now we're going to do the other one, which is the conclusion sentence. Okay. First, do you guys see where I got those things from? Since our p-value is small, and so small being less than alpha, less than the boundary, we reject the hoe. Reject it. Okay, what are we trying to find convincing evidence of? The ha, right? So this last statement here is always about the ha, because that's what you're trying to show. You either have convincing evidence for the ha, or you don't have convincing evidence for the ha. So the Done. I do have a joke for you, and I think it's actually a really good one. It's a teaching joke, but it's also funny. This is not this is the joke. It's not funny. That's not funny. It's not funny. Monday's joke is funny. This is just before I got all into my printing out my thing. But mentally prepare for liking Monday's joke.